Izolyator is Russia's largest manufacturer of high-voltage bushings for alternating and direct current. For more than a 120-year history, the plant has gained a unique experience in design, manufacturing, and maintenance of bushings for various applications in the voltage range from 12 to 1,200 kilovolts. This video will introduce detailed information about Izolyator products and their key design and technical features. High-voltage bushings. High-voltage bushings are the most important link between an electrical transmission line and other electric equipment. For an uninterruptible and quality operation, bushings are created to meet the design features of such equipment as transformers, shunt reactors, oil circuit breakers, gas-insulated switchgear. The external and internal insulation of a high-voltage bushing provides a reliable and stable power supply even in the most adverse conditions of the operating environment. High-voltage bushings classification. By operating medium: oil to air, oil to oil, oil to SF6, SF6 to air, air to air. By the type of internal insulation: RIP, RIN, OIP, oil, SF6. By the type of external insulation: porcelain insulation, polymer casting, hollow polymer insulator. By application: for power transformers and shunt reactors, high current for power transformers, for cable connection to transformers, for connection of transformer and GIS, for oil circuit breakers, gas insulated for GIS. Beginning in the 21st century, Izolyator, together with leading research centers of Russia, created a unique production technology of RIP insulation based on paper saturated with resin. It allowed to increase the reliability of products and enhanced their service life. In 2017, Izolyator plant developed a design with the newest type of insulation, RIN and RIS. The main difference of those types of insulation from RIP insulation is that a special non-woven fabric or scrim is used at winding instead of paper. Due to the fact that there is no cellulose in the insulation structure, both types of insulation are not able to be moistened during transportation and long-term storage, which allows storage of bushings in any conditions without the use of special sealed cases. The proprietary technologies are protected with 12 international patents, including patents on the making of RIP and RIN insulation and production of the external polymer insulation for voltages from 35 to 330 kilovolts. Let us consider the design of several high-voltage bushings produced by Izolyator. Oil to air, high-voltage bushings for power transformers and shunt reactors. On the engineering side, bushings are feed-through insulators intended for leading in or out high voltage from a transformer or reactor tank and are independent items of equipment. The contact terminal, made of copper alloy, is used for connection of high voltage. Inside the case, these elements of the bushings are placed: gas cushion, some free air or gas to compensate volume fluctuations of the liquid filler caused by temperature changes, tightening device that ensures required mechanical strength and leak tightness of the bushing, oil gauge for control of oil level, liquid filler in the bushing, filler, a dry, gaseous, or liquid substance protecting the bushing's internal space against moistening, porcelain housing, an external insulation of the bushing that protects it from adverse factors of ambient environment and ensures required arching distance and creepage distance along its outer surface. Insulation core is an internal insulation of the bushing, equalizing electric field in radial and axial directions using condenser liners. The last layer of the insulation core is grounded in operation, hence it is called grounded. This layer stays in permanent electric contact with the measuring tap, which is used for taking measurements. So, the second name of the liner is measuring. The central tube is intended for winding internal insulation on it. The central flange is used for fastening together elements of the bushing. The test tap is placed thereon. The mounting flange is used for securing the bushing on the equipment. Sometimes the mounting flange is combined with the central flange. The bottom shield equalizes external electric field in the bottom part of the bushing. The top shield is used in designs of bushings with polymer external insulation for equalizing electric field in the top part of the bushing. In bushings with porcelain housing, the top shield function is performed by the case. Polymer insulation is used on bushings with internal RIP insulation as an alternative to porcelain housing and performs the same functions. Connection to transformer winding can be done in different ways by drawing a cable through the bushing's tube and soldering it to the contact pin in the upper assembly of the bushing, the so-called draw lead type design, by bolting or threaded fastening in the bottom assembly. Then it is not a draw lead type design. In those designs, the central tube or the rod pulled through the tube of the bushing is used as a current conductor. High current oil-to-air high-voltage bushings for power transformers. These bushings are intended for connection and transmission of electric power produced by the generator unit of a power plant to the low-voltage winding of a power transformer. Design highlights of the detachable bushing. No internal insulation. Transformer oil fills the internal space of the bushing. Test tap is absent. Large surface of contact areas. Oil-to-oil high-voltage bushings for cable connection to transformers. The bushing is a feed-through insulator intended for connecting a transformer tap with the cable and sleeve. During operation, the bottom part of the bushing is inside the transformer tank, while the upper one is in the cover of the cable gland. Both parts of the bushing are immersed in transformer oil. Therefore, such bushings are called oil-to-oil. The bushings of the type are peculiar by the absence of external insulation both on the bottom and the upper part of the bushing. The bushing consists of the following elements: a solid insulation core, made by winding of insulating paper on a central tube with subsequent saturation in epoxy compound, RIP insulation. They use conductive liners, separating paper layers to equalize the electric field. A central flange with a test tap on it. In operating conditions, the test tap is connected with an extended test tap, positioned on the plate of the cable gland cover outside. The extended test tap must be effectively grounded during operation. A mounting flange with an eye bolt for lifting the bushing and a stopper for air outlet from the transformer tank. A top unit. A bottom shield. Oil to SF6 high-voltage bushings for connection of transformers and GIS. These bushings were developed in recent years. Bushings of this type are feed-through insulators intended for separating two insulating media. SF6 gas and oil in an airtight switchgear when connecting it to a transformer. In operation, the bottom part of the bushing is inside the transformer tank in the transformer oil medium, while the upper part is in the cover of the SF6 gas compartment. The bushings of this type are characterized by the absence of external insulation both on the bottom and top parts. In their constructional part, these bushings differ from oil-to-oil bushings by the central flange that has two mounting flanges, one for fixing the bushing on a transformer, the other, more powerful, for installing a gas-insulated contour, the top contact unit in the gas-insulated unit, the current conducting assembly rod passing through the entire tube of the bushing. It may consist of several elements. Oil-to-air high-voltage bushings for oil switches. Bushings are the main insulating element of the oil circuit breaker, ensuring its reliable and secure operation. The contact terminal is made of brass and is meant for connecting the down conductor terminal of an aerial power line. The case is used for installation of the following components of the bushings: gas cushion, tightening unit, oil gauge, only for 220 kilovolt bushings, The filler, oil, protects the internal hollow of the bushing from moistening. The porcelain housing is an external insulation of the bushing. The insulation core is an internal insulation of the bushing. The central tube for 110 and 220 kilovolt bushings and the rod for 35 kilovolt bushings are used for winding the internal insulation. The top shield is applied in the bushing designs with polymer external insulation and is used for equalizing the external electric field in the top part of the bushing. With the bushings using a porcelain housing, the case performs the function of the top shield. The polymer external insulation is used as an alternative to porcelain insulation on 110 and 35 kilovolt bushings. Connection to the circuit breaker. The type of connection of 35 kilovolt bushings depends on the type of the circuit breaker which they are installed on. Connection of 110 and 220 kilovolt bushings is done with the help of a contact tip screwed on the central current conducting element of the bushing. Air-to-air high-voltage wall bushings. The bushings are intended for installation in walls and floor slabs of switch houses. Izolyator makes wall bushings only with condenser-type solid insulation core with RIP technology as the most effective. For a possible connection to any of the parts of the bushing, there are contact terminals installed on both ends. Air-to-air bushings can have a porcelain external insulation or polymer finning. A special gel, a dry filler, is used in bushings with porcelain housing. No filler is required when a polymer silicone finning is applied directly on the insulation core. The central flange is meant for mounting the test tap and flange on it. The flange is used for fastening the bushings on its installation place and can be either round or square. Shields are used in bushing designs with polymer external insulation and are used for equalizing the external electric field in the top and bottom parts of the bushing. In bushings with porcelain housing, the function of the shields is performed by the top and bottom flanges. SF6 gas-to-air high-voltage bushings for GIS. This group includes special bushings intended for connection of GIS to power lines. The bushing is a feed-through insulator intended for lead-out of the high voltage from a GIS or transformer and is a separate item in terms of construction. In operation, the bottom part of the bushing is positioned inside the GIS or transformer in the gas medium, while its top part is in the open air. The bushing consists of the following main structural elements: solid insulation core, central flange with a test tap installed in it, which should be grounded in operation, mounting flange with eye bolts meant for fastening the bushing to the equipment, porcelain housing filled with insulating gel, contact terminal, bottom contact unit. This application area is also relevant for SF6 air HV bushings filled with SF6 gas. Their difference is in the simplicity of construction. No insulation core, no equalizing or condenser liners, no need in test tap. However, in order to create an enclosed volume, the bushing has a bottom porcelain housing. To equalize the electric field inside the bushing in the grounded flange area, they use an internal shield. Direct current, high voltage bushings, intended for installation on equipment, which can operate on alternating and direct currents as well as their combination. Direct current bushings are installed on transformers specifically at a nearly horizontal angle, making it irrational to use bushings with porcelain housing. Besides, special fire safety requirements are applied to the bushings of this type, eliminating transformer oil as a possible filler. So modern DC bushings have solid insulation, polymer housing, and dry filler. The bushing consists of the following main elements: solid insulation core made by insulating paper winding on a central tube with subsequent saturation in epoxy compound, RIP insulation. Central flange fixed on the core and meant for fastening the bushing on a transformer. There is a polymer housing filled with gas on the bushing. There is a conductor all through the bushing, which has an airtight seal in the top and bottom parts of the bushing. The design office of Izolyator can customize type designs according to the features of the customer's equipment if necessary. Our designers have a unique experience of high-voltage bushings development according to specific requirements of our clients. We continuously develop new bushing designs, both for replacement of operating bushings, including foreign-made items, and for transformer plants against technical requirements of customers with specified characteristics and dimensions. It gives us a considerable advantage over other manufacturers of similar products. Izolyator provides a complete range of technical support services for installed bushings. Our service includes examination of a bushing's exterior, oil pressure check, electrical measurements, heat monitoring,